This video follows up on our chi-squared video, where we compared the proportion of some good or bad outcome between two groups. In that video, we compared the proportion of bad outcomes using division to get relative risk. What if we want to calculate a risk difference? The way that SPSS allows us to do this is by conducting simple logistic regression. Now, the reason that we call it simple is because we only have one predictor variable, but by no means is the process simple. There's going to be multiple clicks here for us to get what we want, because unfortunately the crosstabs output doesn't give us the risk difference and its 95% confidence interval. So we'll go back to SPSS, where we have our data and we have our output from the crosstabs here. If you don't know how to get this, please watch the chi-squared video. So we have our data now, and I'd like to get the risk difference. So to do this, we will go to Analyze, and instead of the descriptive statistics crosstabs that we did last time, we're going to scroll down a little bit further to Generalized Linear Models, Generalized Linear Models. Yes, I said the same thing twice. We'll click in, and as you can see here, you can do all kinds of different linear models. This is a very powerful tool, and we're going to use it to carry out this binary logistic regression. And why is that? Because we have a binary response. We either do or do not have pancreatitis. And so that will be our type of model. What we need to do now is put in our response. In other words, what is the dependent variable? Well, it's not group, it's of course the outcome. My outcome is my outcome. So we'll send that in there. My predictors. Well, that's extremely straightforward. I only have one here. This is simple logistic regression. So we'll add our group factor to the factors box. Fairly straightforward. We'll move on now to the model button. And this just asks, which main effects do we want to calculate? In other words, what do we want to compare across? And this will be more important when we have multiple variables in multiple logistic regression. But for right now, we just have the one. So we'll just add group. Like with linear regression, we can use logistic regression to control for nuisance variables. For example, age, BMI, smoking status, etc., etc. We're going to skip over estimation, nothing helpful there, and we'll go to statistics. And here what we're going to ask it to do is include the exponential parameter estimates. The reason for that is so that we can get things like odds ratios from logistic regression. What you should keep in mind is that the parameter estimates of a logistic regression are the log of the odds ratio. So we need to exponentiate the log to turn it back into an odds ratio. So that's it, just one little checkbox there. And then of course we have to tell it to give us those mean differences. So we go into EM means, or estimated marginal means, and we would like it to display the means for, you probably guessed it, group. We could specify some interactions and stuff like that, but we're not going to do that. And the contrast that we want here is pairwise. Just give me the difference between my pairs. And finally, we'll click OK down here. And we come up with our output. We don't really care about any of this stuff. This is just basic descriptives. We can skip over this. None of this matters. We've got some goodness of fit that really doesn't matter for us. We're not actually trying to come up with some kind of predictive model. So none of that is a very big deal. So we'll keep on rolling down until we get to the table that we actually care about. And that's, of course, the parameter estimates. Now, what I'd like you to notice here is that we have our exponentiated estimate here. So if you exponentiate negative 0.705, it becomes 0.494. We've encountered this before. Notice that's the odds ratio if we scroll back up, that we got from our crosstabs output. And notice the confidence interval perfectly matches. Great, so why didn't we do this in the first place? It doesn't give me relative risk. And that's actually what I care about. Odds ratios are helpful for statistical tests, but they're not really as intuitive to interpret. And so human beings prefer relative risks, while statistical software prefers odds ratios. But this is just to show you that logistic regression is doing the same thing. As we've seen before, there are many ways of doing the same thing in SPSS. Okay. What do we really care about? Down here. We finally got our estimates of risk. So about 83% of the folks didn't develop pancreatitis in the placebo group. 91% didn't develop pancreatitis in the indomethacin group. So 83% had a good outcome in placebo, 91% had a good outcome in the intervention group. Is this difference statistically significant? Of course it is. We've already seen this. If your chi-squared and your relative risk are statistically significant, your risk difference will be too. Almost every time. Okay, so we go down here. Now we're comparing them. These two rows are just showing you different orders. If we subtract indomethacin from placebo, that's a big number from a smaller number, and so we get a negative difference. You can interpret either one. They'll tell you the exact same thing. All we're changing is the sign of things. So we'll look on the bottom here. There was an 8% difference between the two groups favoring indomethacin. 8% more people had a good outcome. What's my risk difference? 8%. I would have to believe anywhere between 2% and 13% though. And there you have it. We got our risk difference and its 95% confidence interval using SPSS. Now, there is actually a much simpler way of doing this, which we will do in the Google Sheets calculator that I made for you in the next video. If you weren't able to conduct your logistic regression, please drop me a question in the questions box so I can help you out.